What's up, guys? I hope you're keeping well. In this video, we're going to do some examples of life contingency calculations. So let's get into it. The first question here, we're using a life table. Use the table and interest rate of 6% per annum to calculate the following. So we've got these four to calculate here using these values. So when we're given a table like this, we can't sub in to the formulas. We know what we're going to do is we're going to be doing it from a first principles perspective. So the first one here that we'll do this, we're calculating the expected present value of an annuity paid in advance for 2 years for a life aged 61. So all that is, so we expect, because there's 2 years, so expecting two payments. First one would be at time zero because it's in advance, so that doesn't need any present valuing or anything. And then the second payment would be at the beginning of the second year. So that needs to be discounted by 1 year. We do this plus v to the power of 1, and then we also need to consider this, which accounts for the probability of the life to still be alive at that time, the time of the payment. And I'll get these values from here. That is pop in the calculator. You might be tempted to put a third, but if I do this, if we do it out in a timeline, if here's time zero, our first payment would be right here, 1 year, 2 years, right? So the second payment would be here. Then the next payment would be here, which is at the end of like the second year, but it's at the beginning of the third year, and our term is specifically for 2 years. So including this payment would be wrong. Anyway, let's get to the next question. Here we are dealing with a term assurance. So this is going to be a term assurance, the EPV, expected present value of a 2-year term assurance benefit for a life aged 61. Let's do this. Sorry. L61. So why we're doing this is because remember this is the term assurance that's going to be paying out on death. So if we've got a 2-year term, 0, 1, 2. If the person dies within here, they'd be paid out over here. If they die over here, they'd be paid out over there. So we're discounting both of these two payments with their respective probabilities. Hope that's a bit of a mess, but I hope that made some sense. So you can grasp some intuition behind it. So, and remember, V is the I hope you know that by now. And we'll get these values from here. Pop this in the calculator. That's that answer. So the third question is, you'll see still for a 61-year-old for a term of 2 years, but how this one is going to be the term assurance product, which is the term assurance is when we're getting paid out on the this is not term assurance, man. This is pure endowment where we're getting paid on the survival of the term. So our term of 2 years, this is the nice one, we just get paid out at the end if we survive. So 2 years, we'll discount the payment by 2 years, and now we have to do B61, right? If this is our timeline here, 0, 1, 2. We're only expecting one payment there at the end of the term if we survive this whole 2 years. So all we need to do is we need that probability of surviving, and we need the present value of this amount. But we're not working with any amounts, we're just calculating these probabilities, not these amounts. So this in a calculator. Cool, that's the answer. And this last one is the expected present value of a 2-year endowment assurance benefit for a life aged 61. So I'm not doing this from scratch because, as we can see, this is for a 61-year-old for a term of 2 years. Same here, same here. So you should recall that the endowment assurance is just the sum of a pure endowment and a term assurance. Right, and we just calculated both of these values. So all that we're going to do is we're just going to calculate the summation of the two, which pop in the calculator, 0.915. Cool. Now onto the second part. Here we're going to be calculating the following using 4% interest rate. So I'm not attaching any live tables or anything, but the values that we should be needing are all here. If not, I'll add another one. The first question we're doing is calculating the present value of a person aged 53. This is a pure endowment payable in 12 years with a benefit of $70,000. Cool. So the pure endowment, that's this one. So let's start by just calculating this. 53 with the line there with a term of 12 years. So you should remember the formula for AX N is equals to NX N PX V to the N times by AX plus N. So now we're just going to be substituting values in. This is going to be A53 minus 12 P 53 V 12 A, that's going to be 65. Cool. Now, this might seem like a lot, but remember this value is tabulated on your life table as well as this one, and we know how to calculate this. So I put it here. A53 is 0.4226 minus 12p53 is the probability of someone aged 53 surviving for 12 years. So that's just going to be 27442.681 over 3.546. I discussed all these formulas in the previous video. And then we're discounting it 12 times. The interest rate is 4%. Negative, how many? 12. And then A65 is also given. I wrote it over there. You can get it from your life table, whatever table you're using. Might be different though. 7. And I'll just pop this all into a calculator. To be cool. So that's not the answer though, because that was for the present value and they gave us an amount. So the present value is going to be equals to multiplied by this $70,000. That's going to be equals to so that's the answer to the second question. Present value of a person aged 53 of a 12-year endowment assurance. Cool, with the sum assured of 65,000. So let's just start by calculating this. We'll do the present value at the end. A 53-year-old, 12 years, and we know that that's the sum of a 53, 12 plus a 53, 12, and we just calculated this one, right? So we already have that. Value here. So I'll just write it down quickly. And 17352. So now all we need to do is calculate the pure endowment part of this, which is it's a simple one. We're just going to discount it 12 times and we need the probability of surviving the 12-year term. So that's going to be 12p53 to that plus 1.0, what was 4%, negative 12, and then here this is 27. Am I right? Yeah. Yeah. Got that in the calculator. That's going to be that answer plus 0.424289. Cool. So now our present value of this insurance benefit is going to be how much? 65,000 times by the 0.59781. In the calculator, that gives us cool. Now the last question here is, let me double check this. 38,857, yes, calculator, yeah, I'm happy. Now the last question, we are calculating the present value of a temporary life annuity for a person aged exactly 50 with an amount of $20,000 paid annually in arrears for 17 years. So this question would have been easier if we were calculating the payments in advance, but now that it's in arrears, we have to just remember this formula. I'll write it here in blue, where A X N is equals to A dot dot X minus 1, but you must also account for this. Okay, so let's get into the question. A50, right, because this is what we want to calculate, and then we'll do the present value at the bottom. That is equals to in advance payments for a 50-year-old term of 17 years minus 1 plus discounting of 17, and that's going to be 17p50. So what we'll do is we know the formula for that, right? I'll write it also here. Formula for A dot dot X N, that is equals to A n px v to the n times by A x plus n. It looks like a lot, but remember that's tabulated and that's tabulated, and we can calculate those two. So there's nothing crazy, we can do it. Let's continue. So I'll sub the values in. It's going to be A dot dot and 50 plus 17 is 6, 7 minus 1 plus v 17, 17 p 50. There's not a capital P, this is like a small p. Looks funny though, sorry. Now, all of these values, we've got A50, 16, no, not sure, yeah, 16 minus 17p50, we know how to do that. We're going to go 26. I've got these values from here, which you can find on your table. That multiplied by the discounting of still 4%, and then A67, which is on your table, 10.016. Minus 1 plus multiplied by 17p50. I'm not going to rewrite. I won't fit this because that's just the same as that. So this value is this, right? You can see 17p50, 17p50. The probability of a 50-year-old surviving 17 years. So now I'll pop this into a calculator and get cool. However, it's not our answer. Remember, we need to calculate the present value. Present value is equals to, it was 20,000 multiplied by 11.30992. And in the calculator, this gives me cool. So that is the answer. And if we look at this last question, you can imagine that if we did this exact same question, but perhaps for somebody aged 20, you can see how this present value would be more, that would be a lot higher, because the probability of a 20-year-old surviving for 70 years is going to be higher than the probability of a 50-year-old surviving the term of 17 years. So cool, thanks. I hope this helped. Keep well.